This is A2physics 6, June 09, and this is question 5. And it's a synoptic question. 4 carbon allotropes, diamond, graphite, Buckminster fullerene, which are also shortened to buckyballs, and carbon nanotubes are 4 different forms of carbon. Although they are all made from the same basic carbon atom, their structures and properties vary enormously. Part A. Diamond is the only transparent form of carbon. Calculate the speed of light in diamond given its refractive index is 2.42. So you know you've got an equation for refractive index from one material to another is equal to C1 over C2. So if you say that the speed of light in diamond is 2.42, the refractive index of diamond is 2.42, and that's N1, N2, then you're saying C1 is the speed of light in air or a vacuum, which is 3 by 10 to the 8 over C2. Therefore, C2 is equal to 3 by 10 to the 8 over 2.42, and that gives you an answer of 1.24 by 10 to the 8. Part B. The repetitive structure of the buckyball was revealed using a technique known as electron microscopy, which relies on the diffraction of an electron beam. Figure 5.1 illustrates the structure deduced. Explain why an electron diffraction pattern is achieved. Explain also why the electron wavelength must be similar to the separation of the carbon atoms in the buckyball. So first of all, if you're going to get diffraction, then you must have your electrons behaving as waves. And it must be a wave because waves can be diffracted. Secondly, because of the regularity of the atomic arrangement in the buckyball, then the ball behaves like a diffraction grating. Where the spaces between the atoms are behaving like gaps where the waves are being diffracted from. And the electron wavelength must be similar to see an observable diffraction pattern. Okay, so do your best to explain these and get your 3 marks. And then there's 1 mark for, obviously, again, this should be written in continuous prose. The minimum separation of the carbon atoms is 0.1 nanometers. Calculate the speed of the electrons if they are to have an associated wavelength of this magnitude. And so we're saying that the wavelength of the electrons is 0.1 nanometers. Now you have an equation that lambda is equal to h over, which is Planck's constant, over the momentum. And momentum is equal to mv, so that's equal to h over the mass of an electron times their velocity. And therefore, if we are going to calculate a value for v is going to be h over m lambda. And so h is 6.63 by 10 to the minus 34. Mass of an electron is 9.11 by 10 to the minus 31. And the wavelength we're given here is 0.1 nanometers by 10 to the minus 9. And that's going to give you an answer of 7.28 by 10